Hi everyone, welcome to our video on more challenging matrix multiplication. So in the last video we showed just two matrices getting multiplied, so it's a little messy now, but that's what we did. Here we've got different cases and some of the other operations as well, so we got plenty of space, or at least I hope. Alright, so let's see how it works when you've got different styles of matrix multiplication problems. So in this first one it says this is 2 times b times a. And we can write that out. Actually, let me change it to black ink. There we go. Okay, so 2, and then here I'm just going to write in b. So b is 5, negative 3, 2, 6, 1, negative 4. And then let's write in a, which is 1, negative 2, negative 2, negative 4. Okay, so that's what this one looks like so far. Now, when doing these matrix multiplications, I usually say, so remember that this is called a scalar, this 2 that's on the outside, just this random constant. So I usually look to simplify what's inside of here first. Let me go ahead and do it in blue. So, or actually, yeah, blue's fine. So let's say this is what I would multiply first. I think it makes things a little easier. So I would say set this equal to, let's actually move it down here. I think this will be enough room. Set this equal to the resulting matrix, and let's see if they do multiply. All right, so on this, it's this b. So let me point it out here. The size of b has 3 rows and 2 columns. The size of a is 2 by 2. And so we can see, oh yeah, so 2 and 2 are the same. Those middle numbers must be the same to multiply. And then our resulting solution matrix will be the first 3 by 2. Okay, so we know it's going to be a 3 by 2 matrix there. Okay, so let me go ahead and just set up a big one. So 3 rows, 3 rows and 2 columns. Let me do the whole row. So 3 rows there, 2 columns, and then fingers crossed I gave myself enough room. Okay, so this 2 is already moved down there, so I'm just putting a dot. So I'm just showing that I already just rewrote it. And so inside this big blue bracket that I put is this blue matrix once it's multiplied. And so we'll continue our method of multiplying matrices. By definition, we do the row of one of them, the first one, times the columns of the second one. So here we would have 5 times 1 is 5. And then negative 3 times negative 2 would be plus 6, because negative and negative is positive. And then we do it again to the next column, and we just move it to the right for our answer. So we have 5 times negative 2 would be negative 10. And then negative 3 times negative 4 would be positive 12. And then from there, we'll eventually combine those like terms. Okay, and then let's keep it going. All right, so this next one, I'm going to use blue. So this multiplies each of those columns as well. So 2 times 1 is 2. And then 6 times negative 2 would be minus 12. And then let's do it to the second column here. So positive 2 times negative 2 is negative 4. And then 6 times negative 4 is minus 24. So we keep the signs. And then the last one, we've got 1 times negative 4. Or not 1 times, sorry, 1 and negative 4 are the elements in this row, which will multiply those columns. So 1 times 1 is 1. Negative 4 times negative 2 would be a plus 8. And then let's do it one more time. 1 times negative 2 is negative 2. And then negative 4 times negative 4 would give us a positive 16. Okay, so that's what this one looks like so far. And then let's go ahead. I think we could put it right underneath still. So now we're just going to simplify all of these. 5 plus 6 is 11. And then negative 10 plus 12 is 2. Here we would have negative 10, 2 minus 12. Negative 4 minus 24 would be negative 28. 1 plus 8 is 9. Negative 2 plus 16 is 14. Okay, and then our final step is to use the scalar. Remember that scalars just multiply every single element. So we will have 2 times 11 is 22. 2 times 2 is 4. Then we've got 2 times negative 10 is negative 20. 2 times negative 28 is negative 56. 2 times 9 is 18. And then 2 times 14 is 28. And so that's our final answer after the multiplication all done. So we did the scalar, we did the matrices. All right, so that's it. Okay, and so again, I recommend matrix times a matrix first, and then afterwards deal with that scalar. All right, let's see number 2. So number 2 is a squared. So remember when you have an exponent that this really means the same thing times itself. And so that way we could rewrite a times itself. So now let's rewrite the matrices in. So it's 1 and negative 2 and negative 2 and negative 4 times the same thing. 1, negative 2, negative 2, negative 4. Okay, so we do want to expand it. So always expand these powers when we have matrices, because if you're thinking, hey, how about I just square each of those individual elements? Well, no, that's not what would really happen. We want to go through the whole process of what actually happens when we multiply matrices, which is what I often call pencil in the cup. All right, so this matrix and this matrix are each 2 by 2. So just to quickly check, well, those are the same numbers, so that means we can multiply, and then it is in the format of 2 by 2. Okay, so our final answer will also be 2 by 2. Okay, and so let's set that up. Okay, so again, give myself plenty of room. So there's my 2 by 2 matrix, and this is a square matrix. And so from here, let's do our multiplication. So we've got 1 and negative 2 would multiply that 1 and negative 2. So 1 times 1 is 1. Negative 2 and negative 2 would be plus 4. And then let's take that row and also multiply it by the second column. 1 times negative 2 is negative 2. Negative 2 times negative 4 would be a positive 8. And then let's get our last row here, multiply it by those two columns. So negative 2 times 1 is negative 2. Negative 4 and negative 2 would be plus 8. And then one more time, negative 2 and negative 2 is 4. Negative 4 and negative 4 would be plus 16. All right, so there they all are. And then now we can simplify. 1 and 4 is 5. Negative 2 plus 8 is 6. Negative 2 plus 8 is also 6. 4 plus 16 is 20. Okay, so that's it. Okay, so that's if they throw in that type of power. Now on number 3, they have B, C, A. So all 3 of them. All right, well, let's write them all out. So B is 5, negative 3, 2, 6, 1, and negative 4. C is that X, 4, negative 3, 2y. And then A is 1, negative 2, negative 2, and then the negative 4 right there. Okay, so let's see. Oop, that's being weird there. Okay, so I think that's better. Okay, so there's our setup for it all. All right, and then now I want to multiply this out. Well, first thing we should do is again, make sure that they do multiply. This has 3 rows and 2 columns. This is 2 by 2. So the 2 and the 2 match. Our answer would be a 3 by 2 matrix. Okay, so that's the answer for these first 2 multiplying. Okay, so that would be once we multiply, I'm just going to kind of highlight those getting multiplied. So that would be the answer, and then afterwards we would need to multiply it by a 2 by 2. So just to put that to the side. Okay, just to make sure we can multiply that too. So that answer from the previous one, those middle numbers are the same. It looks like our final answer should be 3 by 2. So final size answer is 3 by 2. All right, but I'm not going to write a final answer size box yet. Let's go ahead and do it in this order. So we do need to multiply these matrices right here first. Okay, so we've got this becomes, okay, so we said 3 by 2. This should be a 3 by 2 matrix once it's all done. I hope that's enough room. And then let me at least put that there. That last matrix still as a, because it will be there, just we need to simplify all of this big one first. Okay, so we did say it's going to be 3 rows and 2 columns. So there's the 3 rows and 2 columns. All right, so it's going to get a little messy here, but let's do it. We've got our first row. We'll multiply each of those columns. So 5 into x multiply to give us 5x. Negative 3 and negative 3 multiply to give us positive 9. And then continue with it. Let's multiply. 5 times 4 is 20. Negative 3 times 2y would be minus 6y. Okay, so there's those. And let's keep it going. So we have 2 and 6 now multiplying x and negative 3. So 2 times x is 2x. 6 times negative 3 would be minus 18. And then we have 2 times 4 to give us 8. 6 times 2y would be 12y. And then one more time, we got 1 times x would be x. Negative 4 times negative 3 would be positive 12, so plus 12. And then we have 1 times 4 is 4. And then negative 4 times 2y would be minus 8y. Okay, so there's this one. Almost ready. Well, let's see. Does anything simplify? Let's see. It doesn't look like it. Okay, so it doesn't look like there's any like terms in these individual elements. So what that means is, I mean, I could rewrite it if I don't want the colors to be distracting, but I hope they're not that bad. I'm going to keep the colors and just say, hey, let's keep going and use our property. So we have a 3 by 2 matrix and a 2 by 2 matrix. We already know that that's going to be a 3 by 2. So let's get those. There's the 3 rows, and here's the 2 columns. Actually, sorry, in case you're writing really fast with me, let's make sure that we've got lots of space, because I'm not sure what's going to happen yet. So 3 rows and 2 columns. Okay, so this might be better. Okay, and so now let's get our multiplication going. So this 5x plus 9 will multiply the 1. So 5x plus 9 times 1. And this is where it might be a good idea to go back to some parentheses and showing the actual multiplication. So there's the 5x plus 9 times the 1. And then we'll do plus the 20 minus 6y in parentheses timesing the negative 2. Okay, so I did need more space. Okay, so there's that first part. And then now let's also take the same first row that we just did and multiply it by our second column there. Okay, so we have 5x plus 9 times the negative 2, and then plus the 20 minus 6y in parentheses timesing the negative 4. Okay, so mine was a little too small. I'll adjust it for the next line. Okay, so that is negative 4. Just make it extra bold. Okay, and then so these are going to take some time to simplify, but let's not worry about that yet. Let's now do our second row times those 2 columns. So we have 2x minus 18 times 1. And then plus the 8 plus 12y. Oops, that's a 2. I need 12. So 8 plus 12y in parentheses times the negative 2. And then we'll take the same row and multiply it by that second column there. So 2x minus 18 times that negative 2. And then we have plus 8 plus 12y times the negative 4. Okay, so that's a little better. Okay, so we've got, again, it's going to get messy here, but so far this is as good as it gets. And then now let's take this last row and multiply. All right, so our last row multiplies each of those columns. So we have x plus 12 times the 1, and then plus the 4 minus 8y times that negative 2. And then one more time, x plus 12 multiplies that negative 2 plus 4 minus 8y will times the negative 4. Okay, so and with parentheses like this, at least, remember we can kind of check. Notice right here, these are all 1s, and then these are all negative 2s on going vertical here in the second part of our multiplication. And then same deal with this. These are all negative 2s right here, and then these are all negative 4s right there. So it looks like the setup's good. And then notice like 5x plus 9, 5x plus 9, those are each first. 2x minus 18, 2x minus 18, x plus 12, x plus 12. So it looks like the order, everything's there. So you can kind of see the exact organization when we don't multiply immediately. So here I'm using the parentheses. All right, but now that it is set up, now we have to simplify. Okay, so I think that just leaves us with just enough, hopefully enough room. All right, so doing it, let me just set up our first matrix bracket there. So we have, so this will distribute, so the 1 distributes, and so will the negative 2. And then after that, we'll look to simplify. So we have 5x times 1 is 5x, and then 9 times 1 would be 9. And then the negative 2 distributes, it would give us, okay, and this plus would also distribute, but negative 2 times positive 20 would be minus 40. And then negative 2 times negative 6y would be positive 12y. So there's our first element so far. Let me go ahead and we'll even underline it, and we'll set up our space again. Okay, so there's the organization. And then still just keep at it. So these are just really a practice in patience with your distributing. Okay, so the negative 2 and this one distributes. So it would be negative 10x and then minus 18. And then this negative 4 distributes. So we'd have minus 80 and then plus 24y. Okay, and then keep it going. All right, so the next one, the 1 distributes, and we'd have 2x minus 18. The negative 2 distributes, we'd have minus 16 minus 24y. And then the second element in this row would be, so the negative 2 distributes, so we'd have negative 4x, and then plus 36. And then we would have minus 32 minus 48y. Okay, so I'm showing the distributing, all done. Make sure the signs are good. Last time we got to do this distributing, the 1 distributes to give us x plus 12. And then the negative 2 distributes to give us 2 times 4, and the negative is minus 8. And then here we'd have a positive 16y. And then one more time, we've got negative 2, and x is negative 2x minus 24. And then the negative 4 distributes, minus 16 and positive 32y. Yikes, look how long this one is. Okay, so the ones with the letters in it really stink it up, huh? Because it's going to take extra time. Okay, and then from there, our final answer. Okay, so hopefully the other problem doesn't involve as much room. But now it is just collect like terms in each of your 6 elements. Okay, so like 5x has nothing to combine with, but these constants in the middle can combine. Okay, so I'm just going to show like in the highlighter, those combined. So we would have minus 31 and then plus 12y. And then let's do that to all of them. Okay, so that's that first element. The second one to the right, so negative 10x looks like it's by itself, but the constants there in the middle combine. So we have negative 10x, and then that would combine to be minus 98, and then we have plus 24y. So there's that one. Okay, and then again, keep it going. This next one, we've got 2x. The middle terms would become minus 34, and then minus 24y has nothing to combine with. And then our second one in this middle row, we've got negative 4x plus 4 minus 48y. Okay, so the 36 and the minus 32 was the plus 4. Then we have x. 12 minus 8 would be plus 4, and then plus 16y. And then this last one, negative 2x. The middle terms become minus 40, and then we have plus 32y still attached. Okay, so finally, huh? So that one's real tough. Okay, so if you could do this, though, I'm assuming you could do any matrix multiplication. Okay, so this one I think is as tough as it gets. Okay, so there it is. So it is the 3x2 that we said at the beginning. Everything's looking good. Or at least I hope everything's looking good. Okay, so hopefully I didn't mess up any of the arithmetic. I mean, with the number of steps, that is a very common mistake, is just forgetting to multiply with a negative or accidentally just going too fast. Okay, so still take your time with these. Okay, so let's take care of this last one here. So b times c minus a. So this one I hope is a little nicer. I'm going to scroll up so I can see all of those. So they're recycling the same matrices. So I have b right here. Oops, let me not write b. I want to actually write what b is. So b is that matrix 5, negative 3, 2, 6, 1, negative 4. And then big old parentheses, c is x, and then 4, negative 3. Oops, let's get the matrix bracket in. So x, 4, negative 3, 2y. And then they said minus the a, which is 1, negative 2, negative 2, negative 4. And then the big parenthesis. Okay, so just like regular old numbers that aren't involving matrices, when you have the big parentheses there, it is telling you need to do those first. Okay, so this does become, so I'm just rewriting that first matrix. And then here in the parentheses, we would subtract. They are the same size, so that means our answer is 2 by 2. And I'm just setting it up. And we do the subtraction, so x minus 1 is the first. And then 4 minus negative 2, so that's 4 minus negative 2 for the second element. And then we have negative 3 minus negative 2. And then 2y minus negative 4. So we got to be careful of those double negatives. Okay, but and I didn't do the lines. You could always put those lines in for organization. So with addition or subtraction, I sometimes don't put them always in there. Okay, and so what this becomes, though, is the 5, negative 3, 2, 6, 1, negative 4. And then here, we could reduce those, and we get still x minus 1. This would be really 4 plus 2, so that's 6. And then we have negative 3 plus 2 would be negative 1. And then that last one looks like it would stay 2y. 2 negatives, though, would become plus 4. Okay, so there we go. And then now that we're multiplying again, we got to make sure that we can multiply. So this one is 3. Let's just put it over here. So this first matrix is 3 by 2. The second matrix is 2 by 2. So that means, yes, we can do it. Our final answer will be 3 by 2. Okay, so we've got 3 rows and 2 columns. Okay, and I hope that's enough space. And on this, we might have to just say that will be the final answer if we can't write any more. So we might need to simplify, but let's see. Okay, so one last time here with multiplying. We've got the row. Oh, let me keep my same color code. I usually start with purple. So the first row times the first column goes in this first top left spot. So we have 5 times x minus 1. And then plus the negative 3 times negative 1. Okay, so there's that. And then now this first row is going to multiply the second column. 5 times 6. Now that one I am just going to say is 30. But the negative 3 times the other one, I'm using parentheses. Okay, so the negative 3 will times 2y plus 4. Okay, and then keep it going. All right, so 2 and 6 now multiply these same columns. So 2 times x minus 1 plus 6 times negative 1. Okay, so that one also, let's go ahead and do 6 times negative 1 would be negative 6, just like that. Okay, and then keep it going. 2 times 6 is 12, and then 6 times the other one, so plus 6 times 2y plus 4. Okay, so we will need to distribute, and then from there, simplify what we can. Okay, and then one more time. Okay, so 1 times x minus 1. And then negative 4 times negative 1, let's just say, is plus 4. 1 times 6, let's just go ahead and say, is 6. And then negative 4, so the plus the negative 4 times the 2y plus 4 is the last element there. Okay, and so I'm going to run out of room, but let's do one last step. So this problem there to the left, just kind of squiggling it. Let's go ahead and at least simplify one more time. So we've got over here, this would equal. So I just want to show, like, hey, just make sure to distribute correctly, and then from there, still collect like terms. So 5 will distribute, and we'd have 5x minus 5. Let's go ahead and set up our matrix. So 5x minus 5, and then really negative 3 times negative 1, we could just say is plus 3. And then from there, we could collect the like term, the terms, negative 5 plus 3, and simplify. Okay, the top right, I do have 30 just hanging out, ready to go. And then the negative 3 would distribute, so we'd have minus 6y, and then minus 12. Okay, and I'm trying to write so I can fit it. Okay, and then just keep it going. All right, so a couple more times. So 2 times x minus 1 would be 2x minus 2. And then we would have just minus 6 attached. And again, from there, we could collect like terms. Then we've got 12. And then the 6 distributes to give us plus 12y plus 24. And then last row, 1 times x minus 1 would be x minus 1. And then plus 4. And then the bottom right elements, we have the 6 hanging out, 6. And then the negative 4 distributes, so we'd have minus 8y minus 16. Okay, and then I can't fit that last step on there, but I will at least just highlight, like this negative 5 plus 3 would simplify, so would those, so would those. And then in our right column, like the 30 and the minus 12 would simplify, the 12 and the 24 would become 36. 6 minus 16 would become negative 22. So we could do one last step, but I think that's good. If you do have questions on it, please let me know. But I'm out of room, so I think that's a good place to stop anyway for this. This one went extra long. Okay, so these matrices are time killers. Okay, so again, take your time on it. Now, don't go too fast because you might end up wasting more time in case you miss something and then you got to redo something. But hopefully everything's looking good. Okay, so if you do have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.